Okay, I'm Kaylee. I'm a PhD student in the Vegetable Entomology Lab, so I'm going to talk to you today about CPB management and warmer weather. So temperatures in Michigan are getting hotter year-round, but they're getting hotter faster in the winters compared to the summers. And that can affect overwintering, which is a really critical stage of CPB life cycles. So in the fall, when the day length starts to shorten, CPB leave the fields where they've been feeding and they move to field edges like around here or woodlots in nearby areas where they can dig down into the soil and overwinter. So beetle survival depends a lot on some factors about how cold it gets. So for example, they survive best if temperatures stay around 32 degrees Fahrenheit. That is affected by how deep they can dig in the soil. So in sandy soils like these, they can dig a lot deeper, which means they have a higher chance of surviving. If it's heavier soils with a lot of clay, they often can't dig as deep. They also survive better if there's some snow insulation that keeps the soil from getting too cold. Obviously, if we have, a polar vortex, a lot more of them die. But if we have warmer winters like we've been seeing, a lot more beetles survive to emerge in the spring. And that means that in the spring, you have higher populations that start feeding and doing damage more quickly. So in the summer, I mentioned year-round temperatures are getting warmer. In the summer, when temperatures are hotter, that also speeds up CPB development. So Colorado potato beetles need about 700 degree days to get through a generation. If you want to flip over your handout, we have a couple of maps here from MSU EnviroWeather looking at degree day accumulation this summer, so from April 1st to August 2nd. This first graph is looking at heat accumulation compared to normal in degree days. So you can see that the majority of the state is ahead of where it normally is. Even a couple places in the state are getting close to about 500 degree days ahead of where they typically are. The second map is looking at heat accumulation compared with normal in days. And once again, you're seeing we're about 1 to 2 weeks ahead of where we usually are in most parts of the state. And this last map is looking at cumulative growing degree days. Again, in the southern part of the state especially, we're getting pretty far ahead of where we typically are. Sophia is working on a CPB specific model for EnviroWeather, so that should be up hopefully in the next couple of years. We'll have some specific data on where the CPB are in their life cycle. Okay, so if you want to flip it back over, not only are these warming temperatures affecting Colorado potato beetle life cycles, but it can also really affect their resistance to insecticides. So CPB are really good at developing resistance to insecticides, and warmer temperatures can speed that up. So the warmer winters, as I mentioned, more CPB tend to emerge in the spring. They're also healthier. They have stronger immune systems if they haven't been experiencing as much temperature stress. And that means they're able to more effectively combat those active ingredients in insecticides. Higher temperatures that also speed up their generation time, as I was mentioning, that can lead to higher selection for resistance. They're just being, selected on more quickly. Additionally, it's likely that some of the same genes that are underlying heat tolerance are also underlying insecticide resistance. So they're kind of getting dual selection pressures there, which can also speed up that insecticide resistance. On the flip side, higher temperatures can sometimes make beetles a little bit more susceptible to certain insecticides. So there are multiple pressures that are acting on the beetles. We're not really sure at this point which force is stronger, but that's important to keep an eye on as you're thinking about how to manage beetle resistance. The warmer summer temperatures can also directly affect some insecticides. Sometimes they break down more quickly in warmer temperatures, and that means that you're going to get fewer days of control. So the efficacy window is going to get shorter for some of those insecticides in warmer temperatures. But there are ways to sort of manage this resistance. So one key thing that you can do is alternate insecticides. So for example, if neonic is applied at planting, so that's a group 4A, try not to apply a foliar neonic later in the season. Use an insecticide with a different active ingredient. That will reduce the number of times that beetles are exposed to the same active ingredient, and which will, reduce the development of resistance. Crop rotation can also be really effective, but to be most effective, you want to rotate into fields that are over a quarter mile away. That's going to make it difficult for the beetles to be moving between fields, so you're going to get all the benefits of crop rotation. Also, this one's really key, only spray when necessary. So if you're scouting, if you're using action thresholds, that will make sure that you're only spraying insecticide when it's necessary, which will reduce the number of times that beetles are being exposed to these insecticides, slowing down, again, the development of resistance. You can also spot treat or use a trap crop. So for example, if you have a lot of beetles accumulating on the edges of fields, that's a great place to spray. That way you don't have to treat the entire field. Using selective insecticides can also conserve natural enemies, so you have a baseline level of control from predatory insects instead of having to only rely on insecticides. And lastly, this is really important, always applying insecticides at the highest recommended label rate. That way, you don't have these pockets of surviving beetles that can pass on resistance genes. You can get really good control and hopefully slow down that insecticide resistance.